Hello everybody, this is Karthikeya. My topic is deep learning for human activity recognition in mobile computing. Deep learning techniques have revolutionized machine learning and its applications in ways no other technologies ever have. This transformation is based on three main breakthroughs, which all co-occurred in mid 2000s. Mobile computing aims to integrate computing into everyday settings, thus making it available to everyone, always. Mobile computing key component in general and for context-free awareness in particular is the automated assessment of what a user is doing. This is referred to as human activity recognition, HAR, and is achieved through analyzing sensor data as it is routinely collected by the mobile platform. Constraints and requirements for HAR from mobile computing are significant. Substantial resources limitations are imposed by the mobile platform. Often near real-time inference is needed. Challenging sensor data need to be processed that include noise, ambiguity, missing data, and so on. Typically, only very limited amounts of labeled data are available that can be exploited for training her models. And ground truth labeling is often of mixed quality or even ambiguous, which complicates training as well as validation. However, the substantial changes of her mobile computing somewhat limit the progress that could be made using those conventional machine learning techniques. With the increasing success and popularity of deep learning methods, demands are now growing to also leverage these techniques in mobile computing scenarios. Her through mobile computing. Her corresponds to the problem of automatically recognizing when a person is engaging in certain activities. So, it is effectively answers the questions of what is a person doing and when. The basis of her systems are observations of activities that are captured using sensors, often focusing on recording movement data. For example, through utilizing body worn inertial measurement units, including accelerometers, gyroscopes, as they are standard in smartphones or smartwatches. The deep learning revolution in her. The deep learning techniques come with the promise of overcoming many of the typical problems more conventional machine learning techniques have with challenging patterns recognition tasks. First and foremost, the potential to eliminate the need for manually specifying appropriate feature representation through automatically learned data representations integrated into an overarching classification model is most appealing to many. Future, future learning for her. Deep learning methods were first introduced into the field of her using mobile computing with the hope of finding more discriminative and especially generalizable future representations. Challenges and new frontiers. Deep learning methods for her in mobile computing have came a long way now, representing the most promising category of analysis methods for a number of challenging analytical tasks. The field as a whole is very dynamic and creative in advancing the state of the art so that improvements can be realized in recognition capabilities and also so these powerful models can be used in next generation mobile computing platforms. To do this, we need to tackle a number of substantial challenges and develop new methods. We have outlined a roadmap for addressing her mobile competing most pressing issues and will describe them below. Personalization. Pers- Personalization empowers technology to implement user specific models that are not reliant on vast amounts of user specific annotated sample data and do not impose unnecessary burdens on the user themselves when bootstrapping a hard system. Key to personalization is the adaptation of generic models. Model optimization. It has been a key item on the wider research agenda for deep learning based R in mobile computing. Impressive results have already been achieved, but further efforts are required to make even the most complex deep model architectures accessible to mobile platforms. Some researchers have already started working on dedicated compilers that translate models into highly optimized, possibly hardware specified representations. More and more functions in our everyday life are reliant on automated analysis, such that they are no longer visible people who use them. This is important particularly for mobile computing based automation in which reliability is of mission critical importance. Just as with other machine learning based pattern recognition domains, deep learning has revolutionized the field of her mobile computing. Impressive recognition capabilities based on challenging analysis tasks are now a reality thanks to years of research and fundamental breakthroughs that have effectively enabled us to leverage the fantastic representation learning and classification capabilities of deep neural network architectures. Thank you.